My name is Frank Straka, Director of Business Development for Panduit's Enterprise team. We focus a lot on, the commercial elements, going into, different markets. One of the big interests for me in this webinar is that if we look at traditionally how our industry has been, right, we've always really focused on the data elements of an installation, right? I mean, I know the RCDD, right, really cool data dudes, those different elements. So it's always been a focus on the data. What we're really seeing a trend towards in the industry is that there's a really big push towards power. And this power is coming, in several different forms. I mean, I think people are familiar with existing technologies there. And one of the things we're really going to focus on this presentation are a major upcoming technology that is really going to revolutionize the way, low voltage power can be deployed in a building. And so with that, again, my name is Frank Straka. With me is Mahmoud Ibrahim, Business Development Manager with Panduit, and he is responsible for Panduit's development in the Class 4 power arena. So we're both going to be speaking today. I'm going to be handling a little bit of the stuff on the front end, telling you about existing technologies, and then he's going to do a deep dive into this new type of technology. So next slide. Thank you. So if you see, right, today in power, there's really a technology called power over Ethernet. It provides data and power to end device. It's ubiquitous, right? It's everywhere. I mean, things, everything in a building is really running off of power over Ethernet. It's a standard-based system, so things are plug and play. You can use different devices from different vendors. And the thing I'd like to mention is new technologies like single pair Ethernet are coming along. So I think everyone knows PoE very, very well. But then there's also stuff like single pair Ethernet that's coming, that's going to be kind of the next generation or next evolution of power over Ethernet to power different types of devices in a building. But that's still all stuff that's pretty low power devices. Class 4 is something entirely new. It's something that we've been spending a lot of time on at Panduit to try to understand and see what products and opportunities there are for us in this space. But it's right now it's vendor specific. It's not widely deployed. So there's a lot of people talking about it, not a lot of people deploying it yet, but we think that is going to change. It's a very safe system. There is a safety standard developed. It's going to be part of the new National Electric Code, as well as there's UL tests. So it's not just us saying it's safe. It's a company like UL that's going to go through testing to confirm that it's safe. And we expect to see still a lot of innovation in this area as it goes forward. So really our goal for this presentation for everyone on this call, develop a better understanding of this new NEC Class 4 power and how it compares to other technologies like power over Ethernet. And so it's, really going to be to decide when to use one versus the other. So that's really what we're going to talk today. And next slide. So I believe now we're turning it over back to you, Mahmoud, to just review some of these different NEC classes of power. You're muted. Nope, still muted.
Okay.
There you go.
Can you hear me okay?
Yep.
All right. Good morning, everyone, and thank you, Frank. Very excited to be talking to you about Class 4 power today, and we're going to take you on a journey. And I think it's just fitting first, before we talk deeply on Class 4 and what's new, just that we quickly touch on the existing NEC classes of power. So we're familiar with 3 classes of power, 1, 2, and 3, and here I'm going to just show you quickly a quick highlight of the differences between them. Class 1, it is not power limited.
I can't hear you.
It has can you guys hear me?
Yeah, I can hear you.
Yes, Mahmoud, you sound good. I think there might have been an attendee that got unmuted, so I've muted everyone's mics now, so we should be okay.
.600 volts and widely deployed. It's really the kind of electricity that's running in our buildings today, 110 or 220 circuits, and it is stringent in terms of installation requirements. So you do have to have an electrician install Class 1 circuits. Class 2, you may be very familiar with, limited to 100 watts, up to 60 volts, and one of the most common applications of it is power over Ethernet. The power part in the PoE is considered Class 2. And by limiting, these are considered limited power sources. By limiting the power and the voltage, it's considered safe from a fire initiation and a shock hazard perspective. And therefore, now you can have a low voltage contractor install Class 2 circuits. Class 3 is very similar to Class 2, limited to 100 watts. However, it has a voltage limit of up to 150 volts. Most common application is home theater and sound systems, and it is considered safe from a fire hazard standpoint, but not from a shock hazard, and therefore you still have to have electricians install it. Now there's Class 4, and NEC Class 4 references a new standard, as Frank was talking. It came out by UL, published last December. It's UL 1400-1. It's referred to as fault managed power. You'll hear so many different names around this new technology, but I like the best way for me to describe it. It's combining the best of both worlds, 1 and 2, combining classes 1 and 2, where you're making the delivery of high voltages safe. So Class 4 is not power limited. It is what's called energy limited. It has a maximum voltage of 450 volts. And what I mean by energy limited, where basically these systems, they're end-to-end systems, and you're trying to limit the amount of energy that a person gets exposed to or a particular fault gets exposed to. And if you're able to adhere to the requirements by this new standard, then you can be deemed a safe, and therefore, based on local jurisdiction rules, you can be installed very much like Class 2 by low voltage contractors. Just in a quick snapshot now, how does Class 4 compare to 1 and 2? So power levels for Class 1, very high power levels. Class 2, limited to 100 watts per copper pair. Class 4, there is no limit on the power level. However, you'll see very typical 600 watts per copper pair. We talked about the installation requirements. So again, given that Class 2 and 4 are considered safe from a installation perspective, you can have a low voltage contractor install them. You do not have to run them in conduit, but that's again very specific to local jurisdiction rules. In terms of wire gauge, Class 1, typically inside our buildings, we're using 10 to 12 gauge. Class 2, very dependent, the gauge is very dependent on power and distance, but you'll typically see anywhere from 14 to 18 gauge. And Class 4, usually you see 16 to 18 gauge. In terms of distance, Class 1 has no limit. Class 2, very limited in range. Once you go beyond 200 to 300 meters, it becomes very inefficient. And therefore, Class 4 has no real limit on the distance. You can see systems going up to typically 2 kilometers, if not more. Here, I'll hand it over to Frank to talk a little bit more about PoE and SPE, and I'll come back and talk to you again, take a deeper dive into Class 4.
All right, thanks, Mahmoud. There we go. So, really, we are not going to spend a ton of time talking about this stuff. I believe many people on this call are going to be familiar, but I think it's good that we just go over it, because I think a good way too to understand what we're doing with fault managed power is different. It's good to understand something versus something you're familiar with. So because we know PoE, it's a good way to start. And I also want to let people be aware of what's going on with single pair Ethernet, because we think that that could be a technology that you also start seeing quite a bit of going forward here. So PoE and SPE, they're methods of running both power and data over a single cable. And that's why they've been so popular, right? Because when you run, people don't, if you have to run, even if the wireless signal, you still need to power the device, right? So PoE is nice. You plug it in, data gets, device gets data and power. Very simple. It's used everywhere. It's plug and play. Everything works with everything else. People like it. Single pair Ethernet, that's a new technology that's coming out. It's really a case where I have it listed there as PoE as overkill. So if you imagine a small sensor, controller, something like that, that takes a very low amount of power, very low data, right? New PoE technologies, you can be looking at 71 watts, 10 gigabits per second. A sensor that's just transmitting temperature probably only needs a couple of watts and almost negligible data rates. But again, because people like using the wired technologies due to their reliability, you do need to have a way to plug it in. So with SPE, we actually kind of take almost a step backwards in terms of the data rate. So it's a lower power rate, lower data rate, but a lot longer reach and a smaller form factor. So you're kind of making a few trade-offs there, but we really think it has some good advantages there. And we are expecting, there is hardware even available now with this technology. It's also referred to as T1L. So go to the next slide. This slide just gives some perspective on PoE port shipments. This, was the best data that I had available to me when I put this presentation together. But you can really see, how common PoE is. I mean, that's PoE port shipments in the millions of ports, and it just continues to grow. And we really see no end in sight here, because as people are changing things, right? I mean, you can see here the penetration, of different devices, CCTV cameras. I remember, probably 5-6 years ago, when people spoke on it, it was, there's a crossing point between, essentially coax-based systems and Ethernet. We're well beyond that point now, but it's a very significant usage of it. I say voice over IP phones, very common for PoE. Though I'll say that that's probably going to drop because I think VoIP phones are becoming less common. However, then there's items like wireless access point sensors, that those just continue to grow and grow. You can even see on the bottom, right, there's elements like lighting. Lighting is something that we've talked about for a long time. Still not a lot of ports though running on lighting. So there's a lot of different, uses for PoE, and really we just see the amount of devices being plugged in just to continue to grow and grow over the coming years. Next slide. So now when talking about a PoE and a like PoE technology, right, a single pair Ethernet. Give common names at the top, just because these are all the different terms we've heard used with it. Single pair Ethernet, SPE, T1L is a term we're hearing used in the industry, as well as there's a technology called PoE, power over a data line, that sometimes can get referred to as such. Data rate for PoE, 10 gigabits per second or 10 Gbps is the highest you can go with it now. Single pair Ethernet, you're looking at 10 megabits per second at 1,000 meters. Right, so PoE, we're talking at 10 gig at 100 meters, 10 megabits at 1,000 meters. So a lot less data, but a lot longer distance. And we think the trade-off makes it a very attractive technology. Power levels, PoE can power up to 71 watts, with the newer high power PoE. That's getting commonly deployed these days. Single pair Ethernet, it's 7 watts to 52, depends on cable length. So even with 7 watts, when we think about a sensor, maybe a controller for a light or something like that, or an HVAC system or building automation system, 7 watts is plenty. So that's really good. We discussed reach. Cable types, Cat5e or higher, Cat6a recommended for traditional. With single pair, there's actually going to be cables out there. There's a SP1 terminology for it, and it's somewhere from 24 to 18 gauge. And then connector type, RJ45, and single pair Ethernet, modified LC. And timeline, obviously traditional PoE has been available for a long time. Single pair Ethernet, I can speak, there is product available on the cabling side available now, as well as there are companies out there making products that do use this technology. Slide. And just to kind of give a framework as to how we see this all falling, down, in terms of how it's going to be used, it's going to depend on how much power you need and how much reach you need. So it's very, very simple, right? If you have a reach below 100 meters, regardless of power, you can use PoE as the device. But when that power is low and below 7 watts, we think in a single pair Ethernet, you could fall in that lower left-hand quadrant. When that reaches above 100 meters, you certainly need a, and power is below 7 watts, that's the ideal use case for single pair Ethernet as well. But then when you need power above 7 watts or above 100 meters, I kind of have it, shaded funny because it may work depending on the reach of the system, or different even technologies may be used. But, if you're going really, really far and you need high power and you need data for all these devices, right now there's not a great use case for that. And so that's just kind of our framework right now on PoE versus single pair Ethernet. I'm going to turn this all back over right now to Mahmoud to give a nice deep dive here on class 4 systems.
Thank you, Frank. And yes, let's take a closer look at class 4. So what's really different here? Past mitigation methods, hazard mitigation methods like we know of for class 2, which we called limited power sources, they're limiting the power and the voltage at the source. And it's great because this type of technology is great because it actually enables cross-manufacturer compatibility. So class 2 systems can talk to each other because they're using the same power and the same voltage. Class 4, however, limits energy delivered into a fault, and there is no one way to design a class 4 system. There are many types of faults that you need to adhere to or detect, different locations where these faults could occur. And so, you know, you'll see in the industry today, there are many names for class 4 and many design options. So in terms of names, you'll hear of pulse power, fault managed power, digital electricity, you name it. There's a lot of names and maybe some confusion around this. But there's also many ways to design a class 4 system. So you could, whatever you have running through the cable could be a continuous DC, it could be a pulse DC signal, it could be AC. There's really no limitation on how you design a class 4 system. What you really need to worry about though is being able to detect the faults that are listed in the standard and be able to detect them quickly. And so we kind of asked the question at Panduit, you know, is there a new naming convention here? Because pulsed DC seems to be one of the most common ways that you'll see class 4 systems created or developed. And so we're all familiar with alternating AC, direct current DC, and so potentially there could be a pulse current PC, which is basically class 4 systems deliver pulse current. That's their method of power delivery. So how does a class 4 system look like? Here I'm kind of showing you it's an end-to-end system, and it will always comprise of a transmitter or a source and a receiver or a converter. The converter or receiver will be somewhere remote, in a remote location trying to power devices, and they'll need to be connected by a class 4 cable. So the UL 1400 standard has two parts to it. -1 covers the systems and -2 covers cable. And really what this end-to-end system is trying to do is continuously monitor for specific faults, and if any of them occur, turn power off almost instantly. And if you're able to do that, again, you're trying to mitigate against shock and fire hazards and could be deemed safe. So this is how it would work. You could think of a transmitter or a source residing somewhere in the head end or somewhere central in the building, head end or an MDF closet. It could be taking DC, it could be taking AC. It's going to convert that into some form of power that is managed, that is being the fault managed by the system. In this case, we're showing pulse current that's flowing through that. It has to be flowing through class 4 cable out to a converter, and the converter, you could picture it being wall mounted, rack mounted, ceiling mounted. It could take so many different shapes and forms. And then from the converter, it will rectify that power and provide whether it's DC or AC to the end loads. One thing to really just highlight here is that there are no class 4 systems out in the market yet. UL just published that new standard, and new systems that come up and comply with UL 1400-1 will be the only ones really considered to be class 4. So I want to take a closer look at that pulse current in the center, what's really flowing through that cable. And here I'm just showing you one way a system could work. So on the left, we're zooming into that pulse, and this is normal operation. So if you think of the y-axis as kind of an on-off, power on and off, and you're doing that so quickly in specified time periods, this power reaches the converter, gets rectified, and powers the end devices. The end devices don't see this pulsing at all. However, this method of operation, what you're doing is you're turning power off and checking for faults. And so in a case of a fault, let's say the fault occurs here in the pulse. Once the system detects it, it goes into the safety check and never turns back on, meaning until the actual fault dissipates. If the fault's still there, the system should never turn back on. So this just shows you kind of one way a class 4 system could be designed. Later on, I'm actually going to show you a live video of a class 4 system that's when a fault occurs. So the two things that I want you to think about right now is, what are those faults that need to be detected or monitored? And then how quickly do we need to respond to them? Those are kind of the two main things that are in the standard that I would like to discuss. So the faults that we need to monitor, I mentioned we're really worried about shock and fire hazards. And I have listed here on the right what those faults actually are. So there's 2 or actually 3 faults under shock, and then there is 4 different faults under fire hazards. If we take a look schematically at what those look like, so you think of T as the transmitter, R as your receiver, and this is just a schematic view of how these faults could represent themselves. So you have the line-to-line resistance fault, you have a short circuit, a series arc, line-to-line arc, and then there's also a 5th optional one. A class 4 system does not necessarily need to adhere to this type of fault. When we look at shock hazard faults, there is really 3. So there is, if you again picture the transmitter and the receiver, and then now we're talking about a person having 2 touch points. It doesn't necessarily have to be the hands. And you basically have 2 copper conductors, so line to line, they're touching each of the lines, line to ground, and then you can also have a line to line from the other pair. So you picture multiple copper conductors sending this class 4 power, and a person touches one cable, one conductor from one line and the other conductor from the other line. All these faults, the system must be able to detect and turn off. So if we compare, just thinking about all these faults that we have to look at, and compare this to existing hazard mitigation methods that we know of. We're all very familiar with GFCI outlets that are in our homes, in our bathrooms and kitchens. Those really are only good for one type of fault. AFCI adds a little bit more protection. It adds line arc and parallel arc. So these are also specific types of outlets. But now you have class 4, which really detects and all 7 different types of faults. And so one could say that class 4 power distribution is really safer than what we have running in our homes today. Now I want to talk about, we talked about the faults, let's talk about how quickly we need to respond to them. And bear with me, the next few slides, there's some math and there's some graphs, and I'm not going to go into a lot of detail, but I just want to give you a flavor of what it really takes to consider creating or developing a class 4 system. So the first thing I want to highlight is, again, we are concerned with limiting energy going into a fault. It's not just, we're not limiting current or voltage or power, we're limiting energy, which is power over time. And UL has defined shock as how much current flows through the heart. And these limits that you see in the graph here are basically the limits that they came with. And these are specified in the standard. So we're going to use this graph to see how we can design a system. So think with me, this is just a very simple example. Let's say I have a system that all it does is just sends a single pulse. That's all it does. The pulse looks like in the graph on the left here, and it has a peak voltage of 400 volts. And I'm trying to figure out for a line-to-line human touch, so someone might actually touch the 2 copper conductors, how long can this pulse last before it is unsafe? So that's what we're trying to figure out here. And so if you go through the calculations based on the voltage and based on what's called the heart factor, which basically is defined as how much current is going to flow through a person's heart if they touch the two copper conductors. You run through the calculations, you get to what's called the maximum heart current. And then you can use this value to go back to that curve and say, okay, I have this much current, how long can that pulse last? And in this case, it's 23 milliseconds. So if you design a system that's just a single pulse and you want to adhere to the standard requirements for line-to-line human touch, you need to turn off that power at 23 milliseconds or before it. It gets a little bit more complicated if you have a system that maybe has multiple pulses, because there's something here that's called the accumulation effect. So if someone touches the copper conductors, every time they could be exposed to multiple pulses, and every time they're exposed to a pulse, the limit of that energy that they can be exposed to drops significantly. And so after a certain number of pulses, the standard would require you to again turn power off so that there's no harm to that person. So here it's again a hypothetical system. You have a peak voltage of 200 volts, and let's say you insert the fault at someone touches the cable at this very first pulse. Each pulse here is 2 milliseconds on, 1 millisecond off, and we're trying to figure out how many pulses can this person be exposed to before they're harmed. And so again, it gets a little bit more complicated, but I do want to highlight this accumulation effect factor here. Basically, all it is, it's with every pulse, that curve that we looked at is shifting down. So it's making the requirement to turn off even more stringent. So we go through a calculation. Right now we get to what's called the current limit, which is listed on the bottom here. And now we can also have what's called the maximum current. This is based on this specific system. The maximum current is 348. And so we go through a calculation and figure out, I'm at 348, the limit is 1165. I'm good on the first pulse. I can go to the second pulse. You keep going down, you can see that the current limit keeps dropping until you get to a certain pulse, and then it basically says, this is too much and you need to turn off. So in this specific system, you can only pulse 3 times. The 4th time, the system must turn off. So again, I apologize for going through this much detail, but I do want to make sure you kind of get a flavor of what's in the standard, and then how that standard will be used by vendors to actually design these systems. Now I'm gonna, since we talked quite a bit about line-to-line human touch, I'm just gonna change it up and show you how a system should behave when a person is exposed to a line-to-line human touch.
You are looking at a demo of a Class 4 system. On the left, you have the transmitter, or source, delivering pulse current through the white cable in the center to the receiver, or converter, on the right. The white cable is a single pair of 18-gauge cable. The converter is powering various loads, one of which are the 3 floodlights above the TV, which are directly fed 48-volt DC from the converter. The TVs are showing you the shape of pulse current flowing through the white cable in the center. This is a fault emulator box that allows us to introduce different faults to the cable delivering pulse current to the converter. The 3 faults presented here are a short circuit, a line break, and a line-to-line human touch. The human touch is represented using a resistor, as if someone is holding both ends of the conductor. Pressing any of those buttons would introduce one of the faults. Now we can go ahead and introduce the line-to-line human touch fault by pressing that button on the fault emulator box. What just happened is that the Class 4 system detected that fault and turned power off almost instantly. You can see that there's no pulse current flowing through that cable anymore. And now the system is checking if that fault is clear. The system knows that the fault is not there anymore, so it takes a few seconds before it turns back on. Now with pulse current being delivered again to the converter, The converter takes a few seconds before it can turn back on and provide power to the lights.
I hope that was kind of a helpful, just a representation of how a system would behave when a line-to-line human touch, or when someone touches the cable. And just one thing to point out here, these systems will typically after a fault, they will automatically turn back on if that fault doesn't exist anymore. So if you just kind of compare that to the GFCI outlet you have in the bathroom or in the kitchen, you always have to go back and retest it to work again. These systems are smart enough to, when the fault is not there, they'll turn back on automatically. Just to quickly touch on cable and connectivity. So we talked about the systems, we talked about the faults that they need to adhere to and how quickly. The standard also covers cable and connectivity. And I'm going to quickly kind of go through that with you. So in terms of cable, I mentioned the UL 1400-2 is a standard for class 4 cable. And this table shows you some of the specs or the requirements to adhere to that standard. So in terms of an insulation rating, your cable has to be able to handle 450 volts at a minimum, but you'll typically see systems out there operating in the 300 volt RMS range. In terms of copper gauge, the standard covers anywhere from 6 to 24 gauge. Again, typically you'll see 14 to 18 gauge cable. It covers solid and stranded. You'll typically see stranded. It covers number of copper pairs, single or multiple, and you'll see typically these cables come in multiples of 2, anywhere from 2 to 8 pairs. Finally, just on the bottom here, some general comments. The standard also covers different construction of cable, so it could be plenum, riser, or general purpose. It could be indoor-outdoor. It could be hybrid. So you'll also see class 4 hybrid cables, meaning there's fiber and copper. And you'll typically see these cables to be twisted, the copper pairs, because when you have multiple pairs in one, it becomes much easier for the installer to identify which pairs work together. And finally, in terms of termination, it's going to be very vendor specific, but you can expect field termination to be very typical. So there are some class 4 cables out there today, and we know that there are more coming into the market as well. But just so you can kind of get an idea of what is available to you today, you'll see anywhere from 14 to 18 gauge, 2 to 8 pair. There are plenum and indoor-outdoor options. There is shielded and unshielded, copper and hybrid. And this chart here just kind of gives you an idea of how big these cables are. So here, kind of a 8 pair, 14 gauge shielded. This kind of almost indoor-outdoor as big as it gets. And then this is kind of the smaller side. And then typically you'll see anywhere from 3 to 4 pair, 16 or 18 gauge plenum rated is the system that's being used inside, the cable being used inside buildings, and it's normally in the less than half an inch, about 0.4, 0.3. I won't talk a lot about the connectivity, but again, the under 1400-1 annexes A and B, they do cover requirements on the connectivity. And just one main thing to really highlight here is the connectors that you end up using with your system must be rated for that minimum of 450 volts. So we talked a lot about the standard, the cable, the faults, but we didn't really touch much on why do we even care about doing all of this? Why does class 4 matter at all? And in this next section, I just want to highlight really the benefits that this brings to you and to your customers, and what applications it applies for. So the first thing is, when you ask why class 4, I like to think of it, it actually unlocks 2 main attributes for us. The first one is you're making high voltage delivery safe. And with that comes a lot of benefits. Obviously, we talked about the potentially a low voltage installer can install it, but even if an electrician is installing this, it's much faster and easier to install. You're using less copper cable. You don't have to run it in conduit, obviously based on jurisdiction rules. But these are a lot of the benefits that come from just that safe high voltage delivery. So there's a very strong sustainability angle to this as well. I mean, you're using less copper cable, you're sending higher voltage, higher than what's in our building, so it's actually more efficient from an OpEx standpoint. The other attribute is centralized power. So you'll see that these systems, because you have to have a source or a transmitter, you have to have a receiver or converter, these sources will typically reside somewhere central. And with centralization comes the benefits of being able to centrally back up, meter, and maintain your entire power infrastructure from one location. It makes it very easy to make moves, adds, and changes. You'll see that these systems are going to be designed to be flexible and hot swappable. So if today you're using it for one purpose, tomorrow you can add more capacity and use it for another purpose in that building. And in terms of applications, you know, sky's the limit. And I'm sure the more you hear about this in the market, you'll see people using it for different applications. And you yourself probably have your own applications that think this technology could be leveraged for. You know, I've listed a few of them here: in-building wireless or outdoor wireless, lighting, smart building, really GPON. Again, there's a lot of applications that, and also across so many different verticals that can benefit from this technology. And now I'm gonna just give you two use cases, just a touch on how this would actually look in a building. So if we look at in-building wireless, or if you're familiar with DAS, distributed antenna systems, this is a primary application for this. Typically, you have in a DAS design, if you think of a building, you have a head-end room, and in that head-end room, you have DAS head-end equipment that's pushing communication up through fiber to radios that are located around the building. And with a class 4 system, you could have the source reside in the head end. You can push the class 4 power up the class 4 cable alongside or the fiber or in a hybrid cable to these remote locations. That copper would hit the converter, and the converter would then provide power out to your radios. So that's just kind of one way of using this. And if you think of a large venue, like a stadium or an airport where distances is significant, you now can have one centralized location for that power rather than having it distributed. And every radio that's connected to it or an access point, if you back up that source, then you've basically backed up your entire installation. And in terms of monitoring, you'll see that these systems come with a lot of monitoring and control capabilities that allow you to troubleshoot things remotely. So that's kind of adding again to the now operational side of this and the benefits of it. The second application I want to highlight is let's think of a smart building. I don't think anyone really can say what a smart building is today and what it will be in the future, but you can think of class 4 power as a DC backbone to any building to enable what that future smart building will look like. We all know eventually what smart building means. There's going to be some devices at the edge, whether it's a sensor, a Wi-Fi 7 access point, a camera. It's just devices at the edge and more connectivity. With more devices, you're going to need power. And so you can think of a solution like this. Again, starting small in a building, you could be using it for DAS. Tomorrow, because it has these hot swappable and flexible features to it, you can leverage it for future deployments. Like if you want to get PoE switches, for example, out on the edge, you can use a class 4 system to power a PoE switch, bring that switch much closer to the edge. This could be very beneficial, especially for, let's say, like healthcare applications, where now these rooms are requiring 12, 24 PoE ports just for the connectivity there. You can imagine the amount of cable that needs to be pulled to that location. Now you can have just a single fiber and a pair of copper going out to a converter to power that switch for you. Again, this is just kind of giving you ideas of where this technology could be leveraged today and in the future. With now, I will turn it over to Frank, and he'll talk a little bit more now about class 4 or PoE and when to use them.
All right, thank you, Mahmoud. It's great talk there. So, really to close this out now, right? I kind of gave some advice earlier on, PoE versus, the newer technology, single pair Ethernet. Now we're going to talk a little bit more in regards to comparing this new class 4 technology to power over Ethernet. And I think you'll kind of see on the summary here as we go through this, it's pretty simple to understand the difference, right? PoE provides data, class 4 does not, right? I mean, that's just a basic element of it. PoE is very standardized in terms of, especially in terms of interoperability. Class 4 is not, right? We don't know that, yet. However, both systems are standardized in terms of safety. So both are very safe technologies, both have independent bodies looking at it. And then you can see that, PoE has a shorter reach, less power versus class 4, a much longer reach, higher power. So I think at a basic level, that's how those two systems will compare to each other. Now, if you go to the next slide, you can kind of see this laid out, in kind of pros and cons versus each, right? So class 4, a lot of power, long reach, it's safe, and you can really change the type of output, right? It's, class 4 is the means of transporting. It gets to that receiver device, which converts it to either AC or DC power. PoE, it's high data rates. It's a proven technology, just meaning that there's just millions upon millions of these devices deployed. We all know it's safe, and it's a very standard and interoperable type of system that can be used, really, anywhere you want. Class 4, now in the cons, class 4, no usable data. We will acknowledge it is unproven. We don't believe there are any known issues, with systems out in the field or systems being developed. However, right, in terms of, compared to a technology like power over Ethernet, it is unproven out there in the market. And there's a lack of system standardization and compatibility. So if you use it from one vendor, try to go to a different vendor, it is not going to work unless, specifically stated. And then with PoE, cons, short, low power, short reach, and it can have a high cost per port depending on how it's being deployed. And so really, the way I look at it is these technologies complement each other, right? You have different advantages and disadvantages to each. And so go to the next slide. So when to use one or the other, right? So first, I give a disclaimer. If data is required, there's no standardized method of running class 4 with data. You can use a fiber cable for it because, the fiber cable will complement the reach of class 4, and it can be run separately or within a hybrid cable. But you can see here, right, just the way I have it broken up is very simple. If the reach is above 100 meters, and depending on how much power you need, it's really going to be either a class 4 power system or, something that may use single pair Ethernet, depending on how much power is needed. Power above 71 watts, always would need class 4 power. PoE just can't do that. And so you really see down here, there's kind of this sweet spot for power over Ethernet where it's going to be, you need 71 watts or less, and the reach is below 100 meters, because in all cases, class 4 power, really has that advantage in terms of the amount of power it provides and the reach. Now, if you go on to the next slide, you can see this kind of broken up graphically, where, you look at this, right, and you see that little red rectangular area. That is the essentially usable space that power over Ethernet uses today. Outside of that red region, that is, really all the class 4 application space that you have in terms of power and distance. So you can see much more flexible technology in terms of the amount of power you can provide. Just for reference, the yellow area, that's essentially what a class 2 system can provide, but the red is specific to PoE. Now, I'll be able to translate this in a slightly different way based on some things I've seen. So right now, if you have a connected building, that red space can serve about 20% of the ports in that building that need power. So if you have a building that's deploying, a lot of different PoE devices, that little red rectangular area there, that's about 20% of the devices using power in that building. So significant. When you add in pulse power, our estimates is that's going to be another 40% of that building could be running using that technology. So right now today, right, 20% of the building is using essentially low voltage technology. Now, when you add in class 4, I've seen estimates that say now 60% of that building could really be run using class 4 power. And that's why I'm, kind of started this call saying, everyone on this call, class 4, it really is, or you guys have always been focused on data. The change we're going to see is that power is going to become a really important part of that equation. So something to think about. And really to summarize, right? It's class 4, it's a great technology. It will be a positive impact on delivering power today. This is not going to replace PoE. PoE is going to still be used, and usage will increase for the foreseeable future. There's also technologies like single pair Ethernet that will also complement PoE, but still not yet widely available as well. As stated, class 4 is complementary. And finally, when you're trying to decide which powering technology you want to use, right, is data required? And how much data do you need? What data rate? How far apart are the devices, or how much reach do you need? And what kind of power do you require? And based on those simple 3 questions, you can kind of see how all these technologies complement each other and can work together. So with everything here, thank you. I'll now turn it back over to Ashley. And I believe there have been some questions submitted, and we will do our best to answer those right now.
Wonderful. Thank you, Frank. And thank you, Mahmood. Great presentation. Very informative. And we do have plenty of questions that rolled in. It did not take long for those to start pouring in. So we'll go ahead and get started. We've got about 5 minutes or so to answer some questions. So we'll get through what we can right now. And if we can't answer them at the current moment, we will follow up at a later time frame to get some of those questions answered after we've completed. So first question that we have is, do these systems rely on software for detecting faults?
Yeah, I can take that one, Ashley. And thank you, by the way, first for listening to us. I hope this presentation so far has been helpful to you. So regarding this question, I'm glad you asked it, because this was also asked to us in the last time we gave this talk at Big C in the winter. And the answer is not necessarily. So in the standard, there's actually 2 different ways that you can go about designing a system. Some of the systems could be software based in the way that they detect the faults, but then there's a whole other track for hardware based. So software based detection has a lot of requirements around adhering to cybersecurity issues, etc. And there is a hardware route that basically means that even if your software does not operate, your system fails safe or can still detect faults. So very different tracks. You'll see systems being designed different ways in the way that they detect the faults.
Great. Next question that came in, what is the form factor or size of this class 4 receiver converter?
So again, it's going to depend on the vendor. It's almost no secret now. The pictures you're seeing are a class 4 system that's been under development at Panduit, and that particular converter is about 10 inches wide and 10 inches long and about 4 inches deep. Really more focused on in-building or DAS applications, but you could see that receiver converter again taking so many different shapes and forms for different applications.
Great. Next question is, does it matter where in the line the fault occurs?
If your system is class 4 compliant, then it shouldn't matter. And I'll give you a little bit more details on that. So the actual standard requires you to test for faults at 3 locations. So you have the class 4 cable, and you have to test for that fault at the transmitter or source, at the converter, and then somewhere in the midspan. And you actually have to then define the worst case for that fault and repeat it. And then you have to repeat all these tests again. So basically, for the safety touch faults, you have to go through a total of 72 tests to make sure that your system works. And that's also just based on a specific cable and at a specific disk length that you're using. If you use another cable, if you're trying to comply with longer length for that cable, you basically have to go through these tests again. So there's really strict requirements around and a high level of testing that's done. So that should really help kind of answer and cover that idea of anywhere on the line, if you touch that, it's going to operate.
Next question, how can you back up the DC system, i.e. UPS?
Yeah, so really, if you're using an AC power to if your transmitter takes or source takes AC power, then you'll use a UPS. If your source uses DC power input, then you can use battery banks, basically. And that's something that's been widely deployed for, especially in the carrier deployments for in-building DAS or outdoor carrier deployments on towers, etc.
Next question, do you need a qualified installer?
I could answer that question right now. So, you know, traditionally, right, I mean, this is such a new technology that, you know, in terms of what a qualified installer means, there's really no formal definition that I am aware of. You know, do I see, you know, something like that coming to be? And, you know, would we recommend that, you know, let's say for a system that Panduit developed, would we provide training and recommend that you use a Panduit installer at that time? Absolutely. But right now, you know, in terms of formal training, because this technology is so new, there is no real, you know, way to do that sort of formal installation.
Great. Let's see. I have two more questions and then we'll wrap up. Can Class 4 and PoE be located in the same wiring bundle?
That's a great question, and I'll tell you frankly that there is some confusion around this right now. So the short answer is yes, they can be. There just are some requirements today, such as putting up a barrier or kind of allowing for I believe it's a 2-inch separation. But really, we have to realize that these kind of requirements that are in the standard today came out almost over a year ago before systems are out, and so there's been a lot of learnings, I would say, between vendors and UL, and I can see the ramifications coming into these standards to kind of make that requirement a little bit more lenient. And because we've tested with, you know, having PoE cables and category cables in the same cable tray and have seen a zero effect of crosstalk or any issues of that sort. And so I think eventually that will be allowed.
Great. Last question to wrap us up. When does Panduit plan to have a pulse power system available?
So full transparency, we are testing our system with UL and foresee to finish the compliance process soon. You'll hear about a Panduit system available sometime in Q4 of this year.
Yeah, and I can add to that. You know, there are technologies out in the market that do look like this right now today. None of these devices would yet be Class 4 certified. The Class 4 standard is new, and you know, we just know that going through the process right now, none of these devices will have yet received a Class 4 certification. So we can make, you know, we did, I think, make a statement. There are no devices out there that, you know, can do this today. While there are devices out there that look like this, they are not Class 4 devices yet because no products have yet been certified to Class 4, and we don't believe the products on the market today can meet the Class 4 specification as it's written. So.
All right. Well, thank you very much, Frank and Mahmoud. Great presentation. And thank you, everyone, for joining us today and sticking it out with us for this presentation. We really appreciate you being on with us.